What is yield used for? Well, it makes any function an iterable. What is an iterable? It is something that we can loop over. So a list it's an iterable, but the key difference is that the yield keyword makes a lazy iterable. It will produce one result at a time. That is, in Python, we call a generator. So a generator is something that will produce results one at a time in a lazy fashion. It doesn't need to produce 100 results or 2,000 or whatever the number is all at once. It will produce one result at a time. Let's take a look at how we can achieve that with practical examples. So again, yield makes any function a generator, an iterable. So let's take a look here first in the first cell where we have some items and we're going to loop with those items on the list. Then yeah, that's fine. That's a regular iterable. Iterable is something that you can loop over. So a list is an iterable, a tuple, a dictionary, they're all iterables in Python. An integer by itself, you can't loop on that, you'll get into trouble. So that's not an iterable. So what is a yield? Well, before we get into that, let's take a look at this one. This is a regular function that tries to append a few numbers into a list and then returns a list. So if I run these, I'm gonna get a list, right? So you can actually do for I in items, and you can loop over that because it's going to return a list. You can print that, and then you're going to have that those items returned, and you can loop over them. So that's fine, but this is eager because it needs to append every single item onto numbers. It needs to produce that list so that it can return the list. So what is the difference with a generator? Well, it's lazy. So this is what makes a regular, the same function, just using yield. So if I run these, then items no longer returns a list. It returns a generator object. So what is a generator object? It's still an iterable, but it doesn't give you all of the results at once. It gives you the results one at a time. So let's loop over this one. So we can say for I in items, print I, and we're gonna get the same. We're gonna get the same behavior. We're gonna get the 1, 2, 3, and 4. That's fine. We can still loop over them, but it is not eager. It's lazy. It's computing each one of these results one by one. So imagine a database that has hundreds of rows and hundreds of results. It doesn't need to grab all of those hundreds of results at once to provide you a list for an iterable. It can give you thing that will yield one at a time, so it will save you on memory. The other use case that I really like is to have an infinite number of results. So here I have a small example where I'm going to generate UUIDs forever. So you have these generate UUID while true, so generate for until the end of times, until you exit out of that, you're going to yield the UUID 4. And I'm going to call it with string here, so I get the string representation. So if you call these, if it wasn't using yield, it will effectively run that until the end of times. But because we're using yield, it's going to generate one at a time. So you can control how many you want. So here I'm saying UUIDs. I'm assigning that to the generate UUID function. This is going to create a generator, and then I can loop over that and say, hey, I want 3 UUIDs. And I can use this next built-in function from Python, which calls every single time it will call the same generator and produce a single result. So if I run this, it will produce 3 UUIDs. If I want 10 UUIDs and I want to run that, it will produce 10 UUIDs. That's fine. And then you can use these generators to produce any number of things. So you can build very flexible functions. So this is also useful if you're reading a lot of text files or super large text files that you want to produce results one at a time, or you want to do highly compute. Like imagine if this was compute intensive, and then you want to like slow it down and not generate, do all of that compute right away, but rather on demand, this is how it will be done using yield. So remember, yield basically turns a function into an iterable that will produce results on demand. That's it.